In the last video, we learned how to multiply a polynomial by another polynomial, but specifically one of our examples was multiplying a binomial by another binomial. And we talked about the way that we do that is by using double distribution or the FOIL technique. Well, sometimes, depending on the binomials that we're given, there's an even shorter way to multiply a binomial by a binomial. And that's what we're going to learn in this video. So in this video, we're going to talk about a shorter way to multiply binomial conjugates, and we'll talk more about what a conjugate is in just a second. And we're going to learn about a shorter way to square a binomial. So the first shortcut that we're going to discover happens when we multiply a binomial by its conjugate. Another way to say that is when we multiply two binomial conjugates together, there's a shortcut that we can take that allows us to circumvent the whole FOIL method or the double distribution method. And that's what we're going to learn here. But first, let's talk about what a conjugate is and how to recognize two binomial conjugates. Here we're asked to multiply two binomials, x plus 2 by x minus 2. And right away I notice that these two binomials are conjugates. And here's how I know. A conjugate of a binomial is the exact same binomial with one glaring difference. And that glaring difference is the sign in the middle between the two terms. If the sign in the middle of two binomials is the only thing that's different in those two binomials, then I know those two binomials are conjugates, and I can use this special way of multiplying to multiply them. So in this case, x minus 2 and x plus 2 are conjugates. Some other examples of conjugates might be a plus b and a minus b. Notice they are exactly the same except for the sign in the middle. Another example might be 2z plus 7 and maybe 2z minus 7. Those would be two binomial conjugates. So take a second and think about it, maybe even pause the video and see if you can tell me what the conjugate of 3x squared minus 4 is. Yep, that's right. The conjugate of 3x squared minus 4 would be 3x squared plus 4. Those are binomial conjugates. So let's first do this the long way, and then we'll discover the short way to multiply two binomial conjugates. All right, let's do our double distribution. The first step would be to multiply x times x, which is x squared. Second step would be to multiply x times 2, which would be 2x. Now here's the double part of the distribution. We multiply the negative 2 times the x, which is negative 2x. And then we multiply the negative 2 times the positive 2, which is minus 4. And then, of course, we're not done until we combine our like terms. And I notice that we have a plus 2x and a minus 2x that we can combine. When we combine those two terms, we get x squared minus 4, because the plus 2x and the minus 2x add out. Now, there's a special name for this expression that we get when we multiply two binomial conjugates. The special name for this resulting binomial, this x squared minus 4, is called a difference of squares. Or you may hear it called a difference of perfect squares or a difference of two perfect squares. And the reason we call it that is because obviously this expression is a difference because we're subtracting two terms. And that difference is a difference of two perfect squares. X squared is a perfect square because it is x times x. And 4 is a perfect square because it is 2 times 2. So this resulting expression is what we call a difference of squares. And we will always get a difference of squares when we multiply two binomial conjugates. And here is where our shortcut comes in. Anytime we multiply two binomial conjugates, the two middle terms, in other words, these two terms, will always cancel out. They will always cancel out. Well, think about our FOIL process, F-O-I-L. The plus 2x was a result of multiplying the outer terms. So the plus 2x was the O part of our FOIL. And the minus 2x was the I part of our FOIL. And in the end, that O part and that I part just went away. We were able to cancel out the positive 2x and the minus 2x. So that means that when I multiply two binomial conjugates, that I don't even have to do the O and the I part of the FOIL. All I have to do to get my final answer is multiply the first terms and the last terms. So to get the final multiplication of multiplying these two binomial conjugates, all we had to do was multiply first times first to get our x squared, and then last times last to get our minus 4. There's our difference of squares, and there's the multiplication. We're done. We don't even have to do the O and the I part of the FOIL. But remember, you can only use this trick when we're multiplying two binomial conjugates. That's the only time this works. The second shortcut that we can take is when we have the specific situation of squaring a binomial. So look at the example on the left. This is an example of squaring a binomial. Why? Because I have the binomial 2x plus 3, and I'm squaring that binomial, or I'm raising that binomial to the second power. Now remember, that exponent of 2 tells me that I have to multiply this binomial by itself, or times itself, twice. So this expression, 2x plus 3 squared, literally means to do this. Take the binomial 2x plus 3 and multiply it times itself, another 2x plus 3. So here I have a FOIL situation. Well, I told you we were going to learn a shortcut, but let's do it the long way first. Let's FOIL 2x plus 3 times 2x plus 3. 2x times 2x gives us 4x squared. 2x times 3 gives us 6x. 3 times 2x gives us another 6x. And 3 times 3 gives us 9. Let's combine our like terms in the middle because we can add 6x with 6x. And we'll get 4x squared plus 12x plus 9. And you may look at that and say, well, I don't really see anything there. Where's the shortcut? Let's look at it a little bit closer. Here's the pattern. Notice that the first term, 4x squared, is just the first term up here squared. It's just 2x times 2x. So when we're squaring a binomial, to get the first term, all we have to do is square the first term. Now that you know that, do you see that the last term in our answer is just the 3 squared? So to get the last term in our multiplication, all we have to do is square the last term of the binomial. So to get the first term, we squared the first term. To get the last term, we squared the last term. Now, how do we get the middle term? To get the middle term, which is 12x, all we have to do is multiply 2x times 3 and then double it. 2x times 3 is 6x. Double that, we get 12x. So we know how to get our first term, we know how to get our last term, and we know how to get our middle term when we're multiplying a binomial times itself, or when we're squaring a binomial. Now that we know the shortcut, let's square the binomial over on the right. We're asked to multiply 2x minus 3, that quantity, squared. So in other words, we're squaring 2x minus 3. Now, if you don't like the shortcut, of course you can just write 2x minus 3 times 2x minus 3 and FOIL that out. But let's use the shortcut. To get the first term of my final multiplication, all I have to do is square the first term. 2x times 2x is 4x squared. Now I'm going to leave some room because I'm going to do my last term next. To get the last term, all I have to do is square the minus 3. Minus 3 times minus 3 is plus 9. Now, to get the middle term, all I have to do is multiply 2x times negative 3, which is negative 6x, and now double that, which is minus 12x. Now, if you do this by FOILing, you're going to get the same result. But because we know the shortcut, we didn't have to do the whole FOIL process and then combine like terms. We just know the end result is going to be 4x squared minus 12x plus 9.